In this operations management video, we're going to introduce statistical process control. The single most important thing to remember about quality is that your customer determines your quality, not you. It's not how well you meet your standards, but how well you meet your customer's standards. So take a cheap wine like Mad Dog 2020 or Two Buck Chuck. You and I might think that that's a horrible wine, but they have lots of customers and lots of customers who are happy with their product. So your customer always determines your quality. Having said that, your customer expectations must be turned into standards. And you want the more important expectations, not the minor ones. Those standards must be something that production can measure. Couldn't be taste, because that's hard to measure on a production line. We then use those standards to measure whether or not we're producing what the customer wants to the best of our ability. Quality control is a process that evaluates our output, relative to a standard, what the customer wants, and takes corrective action when output does not meet standards. And those standards are always based on what the customer wants, or at least they should be. All statistical process control is based on fairly simple business statistics. A lot of it is presented in graphical form, control charts particularly. The business statistics that you're going to use a lot are the normal distribution, confidence intervals, and particularly confidence intervals, and hypothesis testing. The purpose of statistical process control is to monitor the process closely and to monitor it closely enough that we know about quality problems before they happen. If you're supposed to be drilling a hole 1 inch plus or minus 1/10 of an inch, you want to watch the process and see if the mean drifts so that you can correct the problem before it exceeds the customer specifications. In other words, you want to spot problems as they're beginning to develop, but before they become a big enough problem that your customer would bother with them. This prevents subsequent activities from being performed on an item that you're going to end up judging to be defective. So all of your downstream activities are being performed on good items. This raises your productivity. So let's talk about condom testing for a little bit. If you're squeamish about this, you can skip ahead. The customers buying condoms expect them to be highly reliable. In other words, they need to have high quality in the customer's mind. So you may be concerned about color or material or fit, and the customer may care about those as well, but their customer is mainly concerned about them working, about them doing what they're supposed to. Condom makers pull items from the line at random intervals for testing. They do 2 kinds of tests. Half are filled with water until they rupture, half are filled with air until they rupture. This is what's called destructive testing because you can't sell the condom once you rupture it. They're testing consistently, so they're taking large sample sizes and testing them. If more than 2 out of 1,000 fail this test, the entire batch fails and is discarded. That's a pretty high standard. And remember, this is not that they wouldn't have worked, it's just that they ruptured when you put so much water in them or so much air in them. They almost never end up scrapping a production run because they almost never fail this test. They perform a second test. Each condom is placed over a metal mold and dipped in water and hit with electricity. If electricity is able to flow from the metal mold into the water, then they know that there's a microscopic leak in the condom. Any item that fails is discarded. This is fairly unusual in quality control. It is very rare that you test every single item. In spite of that, it's estimated that condoms have a failure rate of 2.3% in the field. Of course, some of that could be to improper use. An inspection is appraisal of a good or service to see if it meets standards. There are 3 points that it can take place. 1, before production. In other words, this is an inspection of raw materials. 2, during production, after you started working on it, but before you finish. And 3, after you finished it, but before you send it to the customer. Inspecting raw materials as they arrive before you use them is called acceptance sampling. You're checking to make sure that the inputs, the raw materials, are acceptable to you. I would argue that if you need to do this, you need to talk to your supplier. I would want to use suppliers where I didn't have to worry about the quality of what they were sending me. Now, of course, sometimes with agricultural products, you don't have a choice. You have to inspect. If you're inspecting during production, you're trying to make sure that the conversion of inputs to outputs is proceeding in an acceptable manner. In other words, you're doing the right things in the process, that your process isn't out of control. This is called process control. You can also inspect it after you've produced it, but before you've sent it to the customer. Here, you're making a final verification of conformance to some standard before shipping it out to the customer. This is also called acceptance sampling. The better your production process, the less of this you have to do. There are 4 basic issues you have to address. One is how much to inspect, and related to that, how often to inspect. Inspecting can be expensive, time-consuming, and, in the case of condom testing, destructive. And a lot of testing is destructive. 2. At what point in the process should inspections occur? I'll talk more about that in a moment. 3. Whether to inspect in a centralized location or an on-site location. I'll talk more about that in a moment as well. 4. Whether to inspect attributes or variables. Variables are measured on a ratio scale. Attributes are a nominal or ordinal scale. You would prefer variables. They're always better with variables, but sometimes you can't get it, so you have to use attributes. So where might you inspect? You might inspect anything coming into the organization, raw materials, purchased parts, and that's sort of an artificial distinction. That's acceptance sampling, and we talked about why you might not want to do that. Your finished production. Remember, just because you finish it doesn't mean it's finished. Your customer is likely another manufacturer. Before a costly operation, because you don't want to spend money to perform an operation on something that's already defective. For the same reason, before an irreversible process, because you can't fix it once the process is done. And lastly, before a covering process, like putting the hood on a car, it's easier to test the engine before you put the hood on. And now, should you use centralized or on-site inspection? Basically, should you take the measurement and do everything you need to do on the production floor or send it off? Some things require an on-site inspection. Building a house, for example, you can't move the house to a lab. But also producing things that are big and heavy, it's just not economical to send it off somewhere else to be tested. Other times, the situation requires specialized lab equipment that might be expensive for you to have on site. Testing meat for listeria, for example. Sometimes you might even have the operators inspect their own work. This is called quality at the source. Of course, this won't work if you need a lot of specialized expensive equipment or expertise to do the tests. In summary, let me give you 2 definitions. Statistical process control is the statistical evaluation of the output of a process during production. Quality of conformance is how well a product or service conforms to the specifications that you develop based on what the customer wants. If you enjoyed this video, please click like and consider subscribing to this channel.